Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Accounting Circles Tessellation by Chinstrap. And here are the rules. We have tessellation, where we need to fill each cell with a digit from 1 through 9. And cells sharing an edge can't have the same digit. So for example, whatever digit is here cannot be in the 8 cells that share an edge with it. For the squares, any digit that's in a square cannot be in the 4 cells that share an edge with it. And also, each horizontal row and vertical column contains a non-repeating non-repeating consecutive set of digits like 2, 3, 4, 5, 6 in any order. So you could have something like 3, 6, 4, 2, and 5, and that would be valid as it follows essentially something similar to like a Renban rule here. And that's the rule set for tessellation. For the accounting circles, we have blue circles and red squares combined form a complete set of the digits 1 through 9. So that means we have in the circles and the squares, there are no repeats, I would believe. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 of the circles and squares combined. And they form a complete set of the digits 1 through 9. A digit in a blue circle indicates how many of that digit appear in the entire puzzle. A digit in a red square indicates that the digit does not appear exactly that many times in the puzzle. For example, if there were 4 4s and 6 5s in the grid, the 4 would go in into a circle and the 5 in a square. So if there are 4 4s, that means there are exactly the number of digits for that digit in that circle. So say this was a 4, that means there has to be 4 4s in the puzzle. If there's a digit in the squares, so say this was a 5, that means there are not 5 5s in the puzzle. And that's what the red squares versus the blue circles mean. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. First things first, let's count how many digits we actually have, or cells that we have. We have 9 and 7 twice, so that's 14. So 9 once, 7 twice, 5 twice, 3 twice, and 1 twice. So that's 1 plus 3 plus 5 plus 7. That would be 8 times 2, which is 16 times 2, which is 32. And then we have plus 41, I believe. Sorry, plus 9, which is 41. Right, so we can just count them too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, 16 on either side. That's 32. Plus 9 is 41. We know, so that means we have the correct number for 1, 2, 3, 4, 5, 6, 7 digits. One thing you probably cannot have is 9. You can't have 9 nines in this puzzle, I'm pretty sure. right? Because if you try to have 9 nines here, if you have a okay, yeah, if you have a 9 here, it cannot be here, right? So if you have a 9 here, it obviously can't be in any of those 3 cells. And you can only have 1 9 per column or row, right? And I think the problem is also if you have an 8, you can't have 8 eights, right? You would have to have 8 eights per row in column. So say you had an 8 here, that would eliminate 8 necessarily from here. Well, you guarantee cannot have a 9. So one of these is definitely a 9. We know that for certain. Can you have an 8? If you have an 8 here, how could you have an 8 where you have it completely situated? 8, then that means you have an 8 here. You would have to have one in every row except for every column and every row except for 1. So 8 could not be here. 8 could not be here in the row. 8 cannot be here in this column. You potentially could have a full 8. 1 you can have only one of if this is the 1. If it's not, then you can't have a 1. Then you can't have multiple 1s, essentially. Because you have to have you guaranteed to have a 1 in column 5 and in row 5. But if it's not here, then 1 has to be the other digit that's not in the amount of in the puzzle, the amount of its digit, right? Can you have 8 is kind of the question. So 8 can't be here. So 8 would have to be, so this would, what would that mean? That means this would be 4 through 8, obviously. This could not be 8. This would have to be 4 through 8. And obviously 8 would not be there. You can, one of these has to be 8 if that's the case. Which means, again, one of these would not have an 8. So this would have to have an 8. So you have 4 through 8 here. 4 through 8 here. 4 through 8 here. One of these would be 8, though. So this could not be 8. This could not be 8. Okay, yeah, you can't have 8. So if you have an 8 here, right, you would have to have one of these be 8, right? Because you would have to have 8 eights in each of the rows in columns. That means one row and one column each does not have an 8. So that means either this or this 8 is not there. But if this is 8, that eliminates 8 from that possibility. And it also eliminates 8 from column 9. So then we would not have 8 eights possible in columns 1 and 9. It would either be, it has to be in one of 1 or 9, but because there's no 1, 9 there, because there's no 9, there's no, sorry. 8 cannot be, it has to be in one of these cells for row 1 or, sorry, column 1 or column 9. But since it has to be in one of those, it cannot be in the other, but then being in one of those eliminates the possibility for being in column 2 for here or column 8 for this cell. So 8 is the other digit that is not in the amount that we think. So I think that means we have to have a 7. So 7 has to be one of these digits here. So whichever one is here, therefore you're guaranteed one of these is a 7. Because it's either a 7, 8, 9 or 6, 7, 8 here. So this cannot be 7. Therefore we know 7. 7 has to appear 7 times in this puzzle. So this is 7, which means this can't be 7. We know we have a 7 here. One of these is a 7. So we have a 7 in one of those two. We have to have a 1, so therefore the 1 has to be there. We have 1 through 7 adds up to 28. That means we have 13 8s and 9s in the puzzle. That's interesting. So this can't be 7. We know this can't be 7. So 7 cannot be here. 7 cannot be here. 7 is in every remaining row. So this has to be... We also have... So we have 7 7s. We either have 7 8s or 8. We have 7 8s and 6 9s, or 6 9s and 7 8s. Because you can't have 8 of a digit at all in the grid, in tessellation grid. Because just necessarily, right? Because if we tried to have 8 8s, and we have tried to have 8 there, it eliminates 8 here in column 2 and in column 9. So therefore, you can only have a certain amount of those. Interesting. But this can't be 8 or 9. Because it cannot... So this is 8 or 9 here, which forces this to be 7 8 9 or 6 7 8. Again, 7 is one of these two. There's only 2 2s. So there's 1 1. Okay, so the 2s have to be in the column 5 and row 5. So one of these 2 circles is the 2. Okay. And then the other one is also on the... It's in the remaining row or the column. So because this is 2, we need a 3 in column 5 and row 5, and then we have an extra 1. So this is guaranteed to not be 8 or 9. We have 2 through 6 here in column 5. Which means we're missing, and this can't be 7. I think because of, well... Ah. Okay, so because of that, I think we know. So 2 has to be, cannot be part of a set of 5 digits. We have to have so again, 1 through 8 add up to 1 through 7 add up to 28 if there's a single digit. If each one matches its digit in the as the number of amount in the grid. Because of that, 41 minus 28 is 13. We can only have 7 of a digit. 2 has to, well, 2 could be here. Ooh, okay, never mind. Can 2 be in both of them, though? Possibly. Uh, if we have a 2 here and a 2 here. So we know. Okay. We know in the 5 renband, the 5 length renbands, which is row 3, row 7, column 3, column 7, you're guaranteed to have a 7. Same with row 4 and row 6 and column 4 and column 6. But because we're guaranteed to have a 7 there, this cannot be 2, and this can't be 2 because of that. um it's probably we have 7 8s and 6 9s, but we don't know. Mm. uh, so the 1 is in the middle, so we don't have to worry about that. But the thing is, the 2 could be in the corners, so we don't even necessarily have. We're guaranteed 2 of each digit. In column 5 and row 5. But technically, you could have. Okay. You have 3 3s, so you have 1 extra 3. You have 4 4s. You have 2 extra 4s. 3 extra 5s. 4 extra 6s. 5 extra 7. Well, we know there's a 7, so there's a 7 not here and not here. This can't be 2. Well, maybe it could be 2. It could be 2, 3, 4. 7 cannot be here. This is 2 through 7. All the remaining dots are 2 through 7. This can't be 7, though. So this has to be 2 through 6. You can't have 2. Okay, you can't have 2 outside row 5 and column 5. So this is either 2, 3, 4, 3, 4, 5, or 4, 5, 6. So we're guaranteed a 4 here. We're guaranteed a 4 here. Hmm. Yeah. Hmm. I think we have. It's almost certain that it has to be 7 eights and 6 nines. Because if you have the opposite, the problem with that is every time you had an 8, you would have to have so you would have to have a 9 in the corner if that's the case. And then every time you had a 9, you would have to have an 8 with it. Um, hmm. um, what does that mean? Okay, so this can't be 7 here. So 7 it's either here, here, or here. We have 6 sixes. Ah, we have 6 sixes. We know we have a 7 in one of the corners. So 6 cannot... Okay, so 6 could be here, technically. We have 6 sixes. So every 5 set has to have a 7. So then this is 3 through 9, potentially. For the 5 sets. No 7 here, no 7 here. That could be 7. Okay. Say that 2 was here. That would force this to be 2 through 8. One of these would be 7. Hmm. No, we have to again, we have to have 7 eights or 7 nines. Because of that, 7 eights or 7 nines. That means every row. So we already guaranteed we don't have an 8 9 here and we don't have an 8 or 9 here. That means every one of these cannot have 3. Because if it had 3, then you can't have, it would be 3 through 8. Right? And then one of these is 7, which means this can't have a 7 here. And you can't have a 7 here. You would have to have a 7 here. If that's the case. Or if this is 7, you can't have a 7 here. You can't have a 7 here, so you would have to have a 7 in every other column. And then you also have to have an 8. Hold up, that's problematic. We don't have an 8 here, we don't have an 8 here, we don't have an 8 here. Did I miscalculate? So 9 plus 7 is 16, plus times 2 is 32, plus 9 is 41. 1 through 7, again, 1 through 5 is 15, plus 6 plus 7 is 28. That leaves 13 digits. Ugh. That's not right. Something's not right here. Hmm. Yeah, you would have 1, 2, 3, 4, 5, 6 eights. Or 9s. And that's too small. Uh, uh, hmm. You definitely can't have 9 9s. That's for certain in this grid. But the problem is that I'm eliminating 7 8s and 7 9s now, which doesn't make sense. Right? Because we have 12 max. Wait, is that true? Yeah, I think it is. Hmm. I think my logic is sound, but then the problem becomes it doesn't seem that way, right? So you have a similar problem here. So then this can't be 3 either. You can't have 3 along here. Hmm. Yeah, it's a little problematic because the reds are both here. And the problem is we need 7 of 8 or 9. We can't have that. Because this can't be consecutive here. We're missing 1 here, we're missing 1 here. That's 3 8s and 9s that we're missing. And since this is 8 or 9, this can't be the 7. Well, because we have an 8-9 pair here, we can't have 8 or 9 here. That's also another problem. Hmm. And because this is eight or well, yeah, because this is eight or nine, you're guaranteed a seven here, which means this can't be seven here. So ideally, this would be the seven, and then we'd have this be not eight or nine. But the problem is that the red eight or nine is there. Um, hmm. Because then you could have something like nine and then eight in that situation, right? Huh. But the problem is that there's not enough digits. Ooh. We can only get six eights or six nines. We can't get seven of either. And then that's too small, right? You have one plus two plus three. You have one through seven, which again adds up to 28, plus six, which is 12, which only adds up to 40, even though we have 41 cells. Ah. Hmm. Uh, dang it. Yeah, you can't have seven nines either, right? Because each one, but then we have the problem of the seven eights, right? You would have to have an eight here to match because the eight can't be there and eight can't be here. Uh, or do you have to have eight and not seven? That's not possible. Yeah, it's just not possible. If you have eight in the corner, that eliminates eight from any of these three cells, right? And then it eliminates eight in the rest in column five. So you can't have eight of any digit. You can only have seven of a digit, but the problem is you can only because of the way that this is shaped, you can't even have that. Hmm. Yeah, that's a problem. Hmm. How does that work? Uh, you just can't have eight of a digit in a puzzle in this puzzle. So therefore, that means eight and nine cannot be the have to be in the squares, I think. Right? Because 8, if you try to have 8 here, that means 8 can't be here and 8 can't be here. But 8 has to be in one of these, right? Oh. But that means this is an 8-9 pair, and then the problem is that you can't have 7 8s or 7 9s, and you need one of them to be 7 to get 13. Man, this sucks. Hmm. Okay, well, let's try it without right now. So then we have to have... That's saying we have to have... Every row and column has to be, except for 1, has to include 9, right? This is a 5 6 5 6 pair, so this can't be 5 6, this can't be 5 6, this can't be 5 6. This can't be 2. So I think 2 would have to be here. So this couldn't be 2 here. One of these would be 3. No, it doesn't have to be 3. It has to be 5. 4 and 5 here, and 5 cannot be here. This is 5, 5, 5, 5, but you could have 2 5s here. This has to be 3 through 9, 3 through 9. This can't be 2. I don't think that works. Yeah, you have 6 8s and 6 9s. So what am I missing here? We just can't have 8. We can't have 8 of any digit. It's just impossible. Because there's 9 columns. If you try to have 8 of a digit, you have 1 digit here, and that eliminates that for column 2 and then column 9. Or if you try to have it in column 9, that eliminates for column 8 and column 1. So you're guaranteed to have at most 7, right? So therefore, the digits which do not appear exactly that many times in the puzzle must be 8 and 9. But then we run into the problem where we can't get 7 8s or 7 9s because of the way that the squares work, right? We try to have 7 here, that doesn't work, right? 7 has to be one of these two. 7 has to be one of these two. But the problem is if 7's here, this doesn't form a 3-length Ren band with 8 or 9, right? And that just doesn't work. So this has to be like 2, but then the problem is, again, this can't be 8 or 9, this can't be 8 or 9, this can't be 8 or 9, so we have 1, 2, 3, 4, 5, 6 8s and 9s total. which is one too small for this puzzle. Ah. Ah. What is this? Uh, hmm. What am I missing here? I don't know. I think I've proven it, you know? You can't have 9 digits, so 9 is obviously not a digit that can be in a circle because you can't have 9 nines. And you can't have 8. So therefore 8 and 9 are in the puzzle, but to form a like if this were here, that would have been fine. If this were in the other row, that would be fine. But we don't have that. So, uh, dang it. Uh, uh, yeah, it's really this square that's the problem. Because of that square, this can't be 7. Because again, 8 and 9 are the digits which cannot appear 8 and 9 times in this grid. There's just no digit that can ever appear 8 or 9 times in a tessellation. But 7's problematic too. Well, yeah, no, it's the problem is the square again. Oh, wait, hold on. You don't have to have 7 in the... Right, you don't have to have 7 in the corners. Okay, that's how we solve it. Okay. You don't have to have 7 in the corners. You could have 7 in every other... Right, because there's 7, right? So you could be in every cell but the corners for the 7, 8s, and 9s, right? That's what it is. Okay. So that's the solve. You don't have to have 7 in the corners. And in fact, you cannot. If you have a 7 in a corner, that eliminates that cell, which means you can't have 8 and 9 there. Okay. So let's clear this out. We know this is 8 and 9. We know this is 8 or 9. So this can't be 7. If we have a 7 here, that eliminates 8 and 9 here. And then we have a problem with filling out the rest of the grid. So this cannot be 7 either. Therefore, we know a 7's not here, a 7's not here. We have to have 7's in all the other rows. So 7 has to be in here, obviously not there, here, or here. Because we also need 1 of 8 or 9 in 7 of the rows also. And the other one has to be 6, right? So then 7 can't be here. This obviously can't be 7. Oh, this has to be 1. That's the only place for 1. Um, this has to be 2 through 6. This can't be 8 or 9. This is 2 through 6. So we're guaranteed. Right, we have to. Okay, we cannot have 9. We cannot have 7 9s. It has to be 7 8s. So we're guaranteed an 8 in each row 2 through 8. Has to have an 8. We don't know about row 5. We don't know where the 7 has to be there. Okay, so that's how we've solved that. So 7 has to be one of these. So we have 6 9s, interestingly enough, right? Okay, these can't be 8. These can't be 8. Okay. So we are guaranteed 7 8s, and we have 6 9s and 6 6s. 6 9s, 6 6s. We are guaranteed in. So since we have 7 and 8 in. Well, that's not helpful. 7 and 8. We guaranteed 7 and 8 in row 5. Sorry, row 3 in row 7, column 3 in column 7. That means it has to be 5, 6, 7, 8 guaranteed in these sets. And you could have a 4 or a 9 here. Right? And then you have 4 or 9 in this scenario. Okay. This obviously can't be 8 or 9. This can't be 8 or 9. This can't be 8. So you can't have 8s anywhere in the circles. So this has to be 6, 7, 8, or 9 here. And this is 6, 7, 8, or 9. So is this. 6, 7, 8, 9, 6, 7, 8, 9, 6, 7, 8, 9. Obviously, this can't be 8 or 9, so we have 6 or 7 there. I think that's... Yeah, you can't have... So if you have a 7 here... If you have a 7 in the corner, obviously that eliminates 7 here and then 7 here. So that necessitates what the scenarios are here. But if you don't have a 7 in the corners, that means every other thing is filled, right? But we don't know for row 5 if there's a 7 in the corner or not. There might be. We know for for rows, row 1 and row 9 cannot contain a 7. Because then otherwise we don't have, again, like we said, we don't have enough 8s or 9s, but basically 8s to fulfill the number of grids of cells in the puzzle, right? We have 41. We would only account for 40 of them if we had a 7 in the corner. So 7 has to be here. This is 2 through 7. This is 3 through 7. Those cannot be 8 or 9. This is 6 or 7. In row 8, we have a 6, 7, 6, 7 pair because, again, they cannot be the red cell. So this is 6, 7, 6, 7. That forces this to be 8. Okay, so we have the 8 here. That means this cannot be... None of these cells can be 8. And these can't be 8. So we're guaranteed this can't be 8 here. One of these two is an 8. Since one of these two is an 8, this can never be an 8. This is a 6, 7 pair. They both see... this can't be 9 here. This can't be 8 or 9 because of 8, 9 pair in the column. This 6, 7 pair sees this, so this can't be 6 or 7. This is 4 or 5. We're guaranteed an 8 here. So one of these is 8. Okay. This is 6, 7 as a pair, so this can't be 6 either. Oh, for 5s, you're guaranteed a 5 in column 3, column 4, column 5, column 6, and column 7. And you're guaranteed a 5 in row 3 through 7 also. And that's all 5 5s accounted for. So you cannot have a 5 outside of those. So this cannot be 5. This can't be 5. You cannot have a 5 here. Interesting. So this has to be 2, 3, 4, or 6, 7, 8. Or 7, 8, 9. Or 1, 2. You cannot have 1, 2, 3 because we already have the 1. One of these two is this. Well, no, wait, that can't be 7. So this is 4 or 5. We are guaranteed. Okay, this is 6, 7, 8. Since this is 6, 7, 8, every other row must contain a 9. Because we need 6 9s. So then this can't be 4. This is 5, 6, 7, 8, 9. This has to be 3 through 9 here. This can't be 8 or 9, obviously. This is 3 through 9. And this is obviously 1 through 9 here. One of these two is 8, so this can't be 8. This can't be 8. Um, so this must be 9. So this cannot be 4, this has to be 5. So this is 5 through 9. No 4, 5, no 4, 5, no 4, 5, no 4, 5. So this is 5, which eliminates 5 there. So 3 through 9, 3 through 9, 5 through 9. This has to be 7, 8, 9. Because we're missing, right. We're missing a 9 here, here, and here. That's 3 already, so this must be 9. So this cannot be 6. This has to be 7, 8, 9. And since this is 7, 8, 9, they all see, oh, both 7s would see here, so this can't be 7. This is 6, which forces this to be 7, which forces this to be 6. So this can't be a 6 anymore. There's no more 6s in here. In column 4. Also, no 6 or 7 here, no 5. This is 3 or 4. Obviously, no 7 there. This can't be 6 anymore in row 3. We have 8 in one of these two. So we have all the 9s accounted for, all the 8s accounted for in each row and column. So these can't be 6. One of these two is a 6 here. So that eliminates 6 from being here. This can't be 6 because it's next to a 6. This can't be 6. This can't be 6 here because of the 6 in the circle. This can't be 5. This can't be 5 here. This can't be 5, and this can't be 5. We know one of these 3 is a 5. That's not helpful. This can't be 5, right? Because we know we have to have 5 5s in rows 3 through 7 and columns 3 through 7. Oh, we know where all the 3s are in row. We know we have to have a 3 in row 4, row 5, and row 6. That eliminates 3 from the rest of the rows, right? This has to be 3 through 9. This must be 3 through 9, and this must be 1 through 9. So this cannot be 3. This is 2, 4 as a pair. That 2, 4 eliminates 2 and 4 in the rest of the row, or the rest of the column, so this is 3, which eliminates 3 here. We have a 4, 5, 7 triplet in the circles. So now we have to eliminate 4, 5, and 7 in the rest of the circles. This can't be 4. This is 2, which makes this 4. This can't be 2, 4, 5, or 7. This is 3 then, which eliminates 3 in the rest of the column. This 3 eliminates 3 in the rest of the row. So 3 could be here. Okay. This could be 4 through 8. We don't know. This is 3 through 9. How do we know that? Oh, because these have to be these rows are guaranteed to be 3 through 9. And rows 4 and 6 are guaranteed to be 3 through 9. Row 2 has to be 7, 8, 9. Row 3 and row 7 have to be 5 through 9. So because of that, and because of the limitations here, that means we know column 3. Column 3. Well, column 3, column 4, column 5 has to have a 3s. So this cannot be 3 here. This cannot be 3 here. Where's the 3 in column 3? In row 6, then it has to be here. So this is 3. Because we know this has to be at least, it's either 2 through 8 or 3 through 9 in these scenarios, right? Because of that, we are guaranteed a 3 here, and there's only 3 threes in the entire puzzle. So this must be 3 here, and 3 here, and 3 here. 3 cannot appear outside, then, of columns 4 through 6 or rows 4 through 6, which means 2 has to be in a corner. Because if 2 is not in the corner, it would have to form a 3-length rim band, which would require it to have 3. So we're guaranteed 2 is in one of the corners, but we don't know if 7 is in the corner or if something else is in the corner, right? We have a 4 here. We have a 4 here, and we have a 4 guaranteed in these 3. Okay, well, that's already done. I was going to say these. Oh. Okay, 4 cannot be on the 3-length Ren bands because it either has to be with 5, which we have too many of, if we have that, and 3, which we would have too many of, if we have that. So 4 cannot be on the 3-length Ren bands. So this must be 7 then. So this is 7, which means this can't be 7. This can't be 7. This has to be 4, 5, 6, 7, 8. So this has to be 6 or 7. This can't be 4, 5. It could be 6, 7, 8. No 4, 5. This is 7 or 8 there. So we know one of these two digits is a 6. That eliminates 6 in this cell. Okay, so we have a 4 here. We have a 4 in column 6 and 4 too, which eliminates 4 in the rest of the columns. So this can't be 4. This can't be 4. We're guaranteed an 8 here. So this cannot be 7 here. We also can't have a 7 remaining in the row. And this can't be 7. This is 4, 5 as a pair. There's no 7 here. Okay, let's remove the outer things. Okay, we know there's a 2 here and a 2 here. This is 4, 5, 6, 7, 8. Therefore, this can't be 4, 5, 6, 7, 8 because we have 4 4s already accounted for in the grid. So this has to be 5, 6, 7, 8, 9. 2 is in one of the corners. This is 7. It cannot have a 5. So one of these two is an 8. Okay, so we know one of these two is an 8. We know one of these two is an 8. We know one of these two is a 6. So these two 8s see that cell, so this cannot be 8 here. How did these get stayed? Anyways. 8 has to be one of these two here. 7's here, we're guaranteed an 8, so this is 6, 8, or 9 here. We know 2 is in one of the corners. We have all 3's accounted for. We have all 5's accounted for. So we're guaranteed a 6 here, 6 here, 6 here, 6 here, and 6 here. So one of these two is a 6. Also. This can't be 7. One of these two is a 7 here. Because this can't be 7. So one of these two is 7. Because... yes, one of these has to be a 7. Because if it weren't a 7, the problem is, how would you form a 3-length rim band? Well, you could have 6, but you can't have 8 here. Right, because you can't have 4 here, you can't have 5 here. The 3s are already taken. And it can't be 2. So this has to be 7 here. Which means 7s is not in any of the corners here then. Okay, so this is 7. Since this is 7, we need an 8 here also. So this is 8. So we have, okay, both of these 8s see 8 here, so this cannot be 8. Oh, so this is 6, 9, and this has to be a 7, 8 pair. Okay. That's helpful. So 8 here, 8 here, 8 here, 8 here. Yeah, we have 8 in every column, except for 1 and 9. Four cannot be in the corners. 5 cannot be in the corners. I think it has to be a 9. Or maybe a 6. Yeah, no 4 or 5. We have all those accounted for. So cannot be 4 or 5. Can't be 1, 3. Can't be 7 or 8 because of a 7, 8 pair here. So this must be 2, 6, or 9. And this is also 2, 6, or 9 also. Okay, right, because one of these two is an 8. That's the reason why we knew this could not be an 8 here. We also knew one of these three had to be an 8, so that eliminated 8 from that possibility. So this can't be 2. So since this can't be 2, okay, this can't be 8 because of 8 in the column. Wait, 2 could be here. Never mind, 2 doesn't have to be here. But 2 could also be here, so 2 could be here. So 2, 4, 5, 6. Actually, we don't have a 4. Yeah, we don't have a 4 in row 5. So it has to be 4 then here. So this is 4, which means this is 2 is in the corner. Okay. So 2 could have been there, but the problem is 4 couldn't have been anywhere else. Right? We knew this was a 4-5 pair because of the circles. Because this couldn't be 4. Because one of these, yeah. Well, wait, why couldn't this be 4? Hold up. That might be wrong logic there. So that being a 7 is not necessarily the case. Everything else I think is good for now. Okay. So I think this is still fine because 2 obviously can't be here. 3 could not be here because again it's in row 3, column 3, row 4 through 6 for 3, and then column 4 through 6 for the 3. So this can't be 3. These can't be 3. This is 4, 5, 7. 5 is in rows 3 through 7 and then columns 3 through 7. And that's 5, 5, so that's all the 5s accounted for. So that's why this can't be 5. Ah, yes, this can't be 4 because if you had a 4 here, you can't have 5 in that column. in column 2, and you can't have 3 in that column, and that's the reason why. So that's why that's 7. So there, okay, yeah. So then everything else is fine. We could have had the 2 in the corner. We could have actually had the 2 here necessarily, but because of the way it works out, we don't have a place for 4. So this has to be 4. Okay. So this is 4, which eliminates 4 here. One of these 2 is 4 here. Where's the 5 in column 4? It must be one of these 2, which eliminates 5 from this cell. We have a 5, 7, 9 triplet in column 6, which means we need a 6 here. So this is 6, this is 7, which forces this to be 8, so that's 6. This 6 eliminates 6 here, so this is 9. This can't be 6 or 9, it's 2. This is 9, eliminates 9 here, so it's 5. That 5 eliminates 5 here, so it's 4. This can't be 5. This can't be 5, 4, or 9, so this is 8, which means this can't be 5, 8, or 9. It's 6. That eliminates 6 here and here. This can't be 6. This can't be 2 or 6, so this is supposed to be 9, which makes this 8, this 6. 8 eliminates 8 here, so this is 7, this is 8. 4 eliminates 4 here, so that's 5. This can't be 9, so that's 5. Where this 8 eliminates 8 here, so this is 9, which makes this 8. So this cannot be 8 here. This 8 eliminates 8 here, so this is 9, which means that can't be 9. That's 7, which makes that 9, which makes that 7. That leaves that as a 5. 8 and 9 in row 6 eliminates 8 and 9 here, so that's 7, which makes this 8. That makes this 4, and this is a 9. Huh. Interesting. Yeah, so I had bad logic with the 7s, but at least I did learn more about how the tessellations work. Oh, it's very cool, actually. It makes you actually think things through about how many digits you can have for each tessellation. So you can only have 7 at most, but you can't have 7. It's interesting. Huh. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.